Good morning, students. Myself, Kiran, working as an assistant professor in the Department of Mechanical Engineering, Global Academy of Technology, Bengaluru. Today, I am going to speak about the transformations in the CAD and computer graphics software. In the previous lecture, we had discussed about the segmentations and other techniques. In this session, we'll speak about the transformations. So basically, what do we mean by the transformations? So transformations are nothing but the different equations which we are going to use in order to translate one point from one location to the other. So here, in the case of 2D transformation, x and y coordinates are required to specify a point in the two-dimensional coordinate system, and these coordinates can be represented using a matrix form as p is equal to x comma y. And similar kind of the representations matrix representation can be used in order to specify a line which between the coordinates x1 y1 and x2 y2, and these are the matrices which are used to represent the line connecting the coordinates x1 y1 and x2 comma y2. And using this matrix algebra, the 2D transformation can be performed on the line or the point. So let us try to know what do we mean. Let us try to learn the different types of transformations that we perform for the line as well as a point. First one is said to be the translation. Translation, that is nothing but it is nothing but moving the element from one location to the other. That means we can translate either a point or a line from one location to the other. And this translation of a point x comma y to a new position, it is nothing x dash comma y dash. So here we are seeing a rectangle which can be moved from one location to the other. This x dash is x, wherein the translation is given by x dash is equal to x plus dx and y dash is equal to y plus dy, where x dash and y dash are nothing but the coordinates which are obtained after the translation, and x comma y are nothing but the points or the coordinates before the translation, and dx and dy are nothing but the movement of the points along x and y direction. So these movements can be represented in the form of matrix as by using this particular equation, that is x dash and y dash, which are nothing but the coordinates of the point which are obtained after the translation, which are obtained by adding x comma y, which are nothing but the coordinates before translation, and m and n are nothing but the coordinates which are used to represent the movements, that is dx and dy along x and y directions respectively. And p dash here, x x dash y dash can be represented by using the vector p dash, which are nothing but the position obtained after the translation, and position of point p is represented by x comma y, which are nothing but the coordinates of the points before translation, and m and n are nothing but the values which are obtained, which are nothing but dx and dy, which are obtained after the translation. So p dash is equal to p plus t. This is nothing but the equation which is used in order to perform the translation. So now let us try to solve one particular problem by using this translation. So here a line is defined by a point 1 comma 1 and 2 comma 4. So now we'll try to calculate the coordinates of a point when these lines are moved by distance of 2 units along x-axis and 3 units along y-axis. So here x1 and x2 are nothing but the points 1 and 1 are nothing but the points x1 comma y1, and x2 comma y2 are represented by the points 2 comma 4. Dx and dy are nothing but the movements along x and y directions. So since both the ends of the line have to be translated at a distance of 2 comma 3 in both x and y directions, so here we do employ the 2 cross 2 matrix. So here in order to perform this translation, we have the equation L dash is equal to L plus T, where L represents the points before the translation, it is x1, x2 and y1 comma y2, which is represented by this particular matrix, and the translation is represented by dx and dy, which is represented by this particular matrix. So adding the two matrices will yield us the translated vector, which is nothing but the 3 comma 4 and 4 comma 7. So here we can see here the original line, which is represented by 1 comma 1 and 2 comma 4, and the translated line, which is given by 3 comma 4 and 4 comma 7. So this is how we perform the translation for the given line here. Similarly, we can do perform the rotation for the given point or as well as for the line here. So here in this kind of transformation, the coordinates point associated with the geometry are related about a point in a two-dimensional xy plane here. So here I am trying to rotate a point along the z. Always the rotation of the point takes place around the z axis. So here the consider so in the next sketch, consider a point P which is attached to the axis OAB as shown in the figure. So here the original point before rotation is nothing but the PA. These are nothing but the PA is equal to PX and PB is equal to PY. So let this point P rotates at an angle Q such that the axis to OAB, which is attached to the point P, is also rotated by an amount Q in the counterclockwise direction, which can be seen in this particular figure. So here when the point P is rotated by an amount Q, even the axis OAB will also be tilted by an amount Q in the counterclockwise direction. So here from figure 2 here we can see that P this from the distance from this point to this point, that is P to P dash, is nothing but the value of Px, which is given by PA cos theta, where theta is represented by Q and Px is given by PA cos theta minus PB sin theta, where the distance from this point to this point, that is from the point P to P dash, is given by PA cos theta minus PB sin theta. Similarly, Py, the vertical distance Py, that is distance from this point to this point, this vertical distance is given by PA sin theta plus PB cos theta, where theta is represented by an amount Q in this particular problem. So converting this above equation into the matrix form will give us this particular matrix, where P dash is nothing but the point which was obtained after the translation, and P is nothing but the PA and PB are nothing but the original points of the point P along x and y directions. And similarly, rotation matrix R is given by cos theta minus sin theta and cos theta. So since here we have rotated the point P axis OAB in counterclockwise direction, always negative sign has to be considered for the rotation in the counterclockwise direction. So now let us try to solve one particular problem by using rotation. So here a line is defined by the points 1 comma 1 and 2 comma 4. This is nothing but represented by x1 y1, and x1 y1 is given by 1 comma 1 and x2 y2 is given by 2 comma 4, which is rotated by an amount theta, which is equal to 60 degree around z axis with respect to the origin in the xy plane. So here let us try to represent this point line by using this matrix x1 x2 y1 comma y2. So here x1 and y1 is represented by 1 comma 1 and x2 y2 is represented by 2 comma 4, and we know that the value of theta is equal to 60 degree, which is rotated around z axis in the xy plane, and the rotation matrix is given by cos theta minus sin theta and cos theta. So applying the value of theta is equal to 60 degree, substituting theta is equal to 60 degree will give us this particular equation, and substituting this value will give us this value 0.5, cos 60 is equal to 0.5 minus sin 60 is equal to minus 0.866, and sin 60 is equal to 0.866, and cos 60 is equal to 0.5. And here we have the rotational matrix equation which is used to represent the point after the rotation. That is L dash is nothing but the line which is obtained after the rotation, and rotation matrix R is given by this particular equation, and the value of L is given, the line is represented by this matrix 1 comma 2 and 1 comma 4. So multiplying the rotation matrix with the basic matrix, that is 1 comma 2 and 1 comma 4, will give us the rotation of the line of rotation of the line. That is L dash is nothing but the line which is represented after the line is tilted by an amount 60 degree. So this is how, and the coordinates of the point which after the rotation is minus 0.366 and 1.36, which are nothing but x1 comma y1, and this is the minus 2.464 and 3.732 are nothing but x2 comma y2 respectively. Thank you.